Okay, so obviously we just ended our last chapter. We're actually going to skip a couple of chapters forward because we want to spend some time before any kind of testing on geometry. So what we did is we're going to chapter 12. That's why it says at the top of your notes. So with that said, you should already have your notes out. Green on the left, notes on the right. Here we go. Today we're going to talk. We're going to start this chapter on circles. And so today we're going to talk about circles, but specifically about the circumference of those circles. So here we go. The very first word is the word circle. Everyone. Circle. All right. So here's what the book says. It says the set of all points in a plane that are the same distance from a given point called the center. All right. Kind of a weird way to think about it. We always think of a circle as like this line that's just kind of curvy goes around, but what they're saying is a circle is on a plane and there's a point and it's all the points that are an equal distance around the center, and it's just a whole bunch of them which ends up creating this circle. All right, so for your note purposes, go ahead and just draw a circle. And what I'd like you to do is also in that circle draw a center to the circle as well, because you're going to find that the center is very important in our vocab today. All right, with that said, our next word is that word right there, center, everyone. Center. So here's what your book says a center is. It says it's the given point from which all points on the circle are the same distance. So it's kind of like the last definition, but just kind of looked at from the opposite end. So, in your little box, go ahead and draw a circle, put the little center dot, and then put an arrow to the center. So when you hear center in this chapter, that's when it's referring to a circle. That's what it's talking about. Okay, our next word, diameter, everyone. Diameter. So here's what the diameter is. It's the distance across the circle through its center. The distance across the circle through its center. So in your little box, go ahead and draw a circle. Draw a center of the circle. And then you can't quite see it, so let me do it here. Draw a line going from one side to the other through the center. That's called the diameter. All right, here we go. The next word. Radius, everyone. Radius. And here's what your book says the radius is. The radius, it says, is the distance from the center to any point on the circle. Distance from the center to any point on the circle. So, in your drawing, go ahead and draw a circle, put the center of the circle, and then from the center of the circle, draw a line to the outside of the circle. That is called a radius. Just really quickly looking at those two, talking about their lengths. Okay? How could you compare the lengths of them? How long they are, that's of course the lengths. How could you compare the two of them though?
The diameter is the radius times 2.
The diameter is the radius times 2. The diameter is equal to 2 times the radius. Right? It's twice as big. So it's like taking the radius and adding it twice means how far it would be across the whole circle through the center. You can look at it the opposite way, right, and say that the radius is 1/2 of the diameter. You think of it that way as well. Okay, so that will be pretty important as we're doing problems because you'll need to understand the relationship there. Any questions about that? All right, here we go. Next word. The word is the main word of this lesson because this is what the lesson's called, and that is circumference. Everyone? Circumference. So your book says it's the distance around a circle. The distance around a circle. So a synonym to this, so in your little box, you can go ahead and put the word perimeter. Perimeter. Now perimeter, perimeter, right? You think of perimeter and it's usually based off of a polygon. I mean, you have straight sides, and so perimeter is the length around the outside of a polygon. Because the circle is curved sides, they just give it a different name. It's called circumference. Okay. All right, now I do have a little bit of a little story time for you today. All right, so not unless you lived in ancient times. All right, so here's what we're going to talk about. Okay, so back in ancient times. Okay, remember that last day before the end of the first semester. That last day of the semester, we watched that little Donald in Math Magic Land, right? And if you remember right, it kind of talked about musical instruments, talked about a lot of things, kind of math all around us, but it referred a lot to ancient times. And that's, of course, where mathematics kind of began. So let me kind of throw this in there. This story is a little bit of, we can call historical fiction, all right? So, meaning that the idea is kind of true in history, but it's not exactly 100% true. But let me share with you guys. You'll still find it fairly interesting if you've never heard of this. But so what we have is back in ancient times, specifically ancient Greece, there were a lot of people that, what many of you guys would maybe be experimenting or playing games on the PS4. Well, their PS4 was actually kind of getting certain things and trying to figure them out like puzzles. And that, of course, what has led to a lot of what we now know about mathematics and how it relates to everything else. So back in those days, they had things that had, of course, were created by straight edges. And they had tools to measure those straight edges that were kind of like that. Okay? So the problem, though, is that they realized that not everything had a straight edge, right? So what they turned around to do is they turned around and found out that obviously things that look like that existed. Okay? And so when we see that, they figured that they were very curious how far it was around this circle, and they wanted to get an exact measurement. And yes, they could take their straight measuring instrument and give maybe a good estimate, but they didn't want an estimate. They wanted to know exactly what it was when it came to the distance around that circle. So after kind of playing around with it for a while, they found their first discovery, and that is they found out if they took this line that goes from one side to the other through the center, also called the diameter, and they took something that was a tool that was bendable, they could get a pretty accurate measurement. So what they did is they could say, okay, well, this line was so much in length, but what they took a look is they took that instrument that was the same length as that circle's diameter, and they bent it around the outside. And they saw that there's 1, 2, and of course it took 3 diameters to go around the outside, plus you had a little bit more left over. And so, they found that was kind of interesting, but doing it once, big deal, right? So of course, what did they do? They turned around, tried it again on a different circle. So, getting that, they took that circle's diameter, and they took that tool and bent it around, and so it took 1, 2, 3 of them, with a little bit more needed. All right, so same kind of ideal situation when it comes to the two circles, right? They're very similar, but in life, right, there still could be coincidences. So of course, they wanted to try another one. And again, you guys, I'm sure, get the idea. Took the length of that circle's diameter, stretched it around the outside, and it took 1, 2, and 3 of them with a little bit left over. Now, what they realized was that that little bit left over was the interesting part. That little bit left over happened to be on every single circle exactly, or almost exactly, 1/7 of the diameter. So what? And that was for every single diameter of its circle. So what they realized was the diameter, it took 3 and about 1/7 of the diameters to go around the outside. And so when it took the 3 and 1/7 of the diameters, they kind of played around with that number a little bit. And they turned around and took 1/7, just converted it by dividing 1 divided by 7, converted it to a decimal, which they then rounded to that right there. And then the ancient Greeks took that number because it was true for every single circle with its diameter, and they gave it a special symbol. And that symbol looked like that. It was a Greek symbol. And of course they gave it a Greek name, and that name is what we now know of as pi. All right, so therefore pi was discovered when it came to circles. So it's a nice powerful tool, because if you take the diameter is this nice straight line. You can find the length of the diameter, but once you find that length of the diameter, you multiply it by pi, you're going to get the circumference. And so it makes it nice and easy. So let's go ahead and let's take a look at our very last word in our vocab, and that is the word pi. Everyone? Pi. And here's what your book calls it. It says it's the ratio of the circumference of a circle to the diameter of the circle. It says approximations for pi are 3.14 and 22/7. And you're wondering about 22/7. Well, take a look. 3 and 1/7. 21 plus 1 is 22. It's the improper fraction form of 3 and 1/7. All right. So in your little box there, you can go ahead and write the symbol. The symbol, guys, is like this little curvy line with 2 legs. Pi symbol. All right, here we go. So what I'm going to have you guys do is, you already have your paper ready.